All right, ladies and gentlemen, now we're going to resolve vectors into x and y components. So far we've taken the two x and y components and we've figured out the hypotenuse, which was the resultant, and the angle that resulted from that. Now we're going to have different pieces that we're solving for. So keep these things in mind, that sometimes you're given that resultant vector, sometimes you know the magnitude of the resultant, and you have to find its components on a coordinate system. And always know that the x and y components are at right angles to one another, and the resultant vector is that hypotenuse. And the sine, cosine, and tangent functions can help you here. Typically, you use sine and cosine if you have a resultant vector's magnitude and the angle provided. Let's try that real quick. So here's a reminder too of the sine and cosine formulas. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. All right, so you have an arrow that's shot from a bow at an angle of 25 degrees above the horizontal with an initial velocity of 45 meters per second. Find the initial horizontal and vertical components of the arrow's velocity. Okay, so this is pretty simple. So there's the vector, and it has a magnitude of 45 meters per second, and it's at 25 degrees above the horizontal, so that means we've got a Vx component and a Vy component initially. So it's not rocket science to look at this and see that this is the adjacent side. So since this is the adjacent side, then velocity in the x direction will have to do with the cosine function, since cosine is adjacent over hypotenuse. So to find Vx, we're going to use cosine. Vy is opposite this 25 degree angle. So to solve for Vy, we're going to use the sine of 25 degrees. So let's try that real quick. So for the sine of angle theta, or the sine of 25 degrees, that's going to be the opposite side Vy over V, which is the resultant vector. So if we solve this for Vy, then we're going to get Vy equals V times the sine of the angle, or sine of 25. So let's go ahead and drop our values in there. So if we take our 45 meters per second times the sine of 25 degrees, then times the sine of 25 degrees, then we find that we have a velocity in the y direction. This component is 19 meters per second upward. Then for the cosine, for the x component of this, same thing. Cosine is going to be adjacent Vx over hypotenuse V. So we drop out this middle explanation to remind you what cosine is, and solve for Vx, and we see Vx is the product of the resultant velocity vector and the cosine of angle theta, which is 25. So in this case, that's 45 meters per second times cosine of 25. So the Vx direction is 41 meters per second. And it's always a good idea to kind of look at this and say, does that make sense? So if you look at this and it's drawn correctly, and this is indeed close to a 25 degree angle, then you can see that this leg of the triangle is longer than this leg of the triangle. So that means that the Vx value should be greater than the Vy value, and it is. So that's kind of a logic check to make sure that you've done these correctly and that you haven't switched the sine and cosine. If this was at an angle like this, then more of the initial velocity would be in the y direction, and the y direction value would be much larger than the x direction value. Okay, try this one. A water balloon slingshot launches a balloon with an initial velocity of 10 meters per second and an angle of 25 degrees above the horizontal. What are the x and y components of the initial velocity? So this is exactly the same problem we just had. We just have a different initial velocity than we had before. So hopefully when you get finished with it, you'll agree that these are the two values that you got. These are pretty straightforward if you just reach back and remember what you know about basic trigonometric functions. Okay, Now you need to do the vector practice worksheet. So you've got 2 sets of practice to do now. You've got the vector homework sheet and the vector practice sheet. And your sub should have both of those available to you. Good luck. Do a good job. Oh, I almost forgot. Most important part. We are going to have a quiz on this the next time I see you. So make sure that you are good at this by Thursday, because this is really something that you should know how to do before you come into my class. So we're just kind of knocking it loose and talking about how to use it in this context. It's my expectation that you are fluent in how to use the Pythagorean theorem as well as how to use basic trigonometry. So the quiz won't be difficult if you know those basic things. However, there's several ways you can kind of get caught if you're not careful with the details. I'll provide copies of the keys for your practice pages, so you'll be able to ensure that you're practicing the correct ideas. Thank you. Sorry I can't be there with you, hopefully. My plan is to be back Thursday.